Okay, so we want to begin our first episode on particle dimension in physics. So several matters we're going to be dealing with in physics. First, we're dealing with particle dimension. So in physics, we have three physical dimensions in physics, three fundamental physical dimensions. But one is mass, two is length, and then three is time. So these are the three physical dimensions we have in physics. Of course, we know that we have our fundamental quantities and our derived quantities at the left hand side of your board, right hand side of you. You're going to see the fundamental quantities and then derived quantities. But then among the seven fundamental quantities we have, these three quantities are the physical dimensions. So that mass is always written as what? Capital letter M. Length is written as capital letter L. Time is written as capital letter T. So we're going to calculate physical dimension for as much as 15 derived quantities in physics. Now, I want to also know that length is also height. Length is also breadth, and length is also distance or displacement. So wherever we see height, it also means length. Distance also means length, and so on and so forth. Let's calculate the first physical dimension. Question 1. Calculate the physical dimension. Calculate the physical dimension area. So what is the formula for area? Of course, look at the table at your right. The formula for area is length times breadth. So you bring out your formula, length times breadth. And then we are going to change it to its equivalent among the physical dimension. Like we said, length, this is it here, and this capital letter L. Breadth is also capital letter L. So I'll be writing L times L. As you have been following our algebra class, you notice that this is going to be L square. L square. So this is the dimensional quantity for area. Next is volume. Pause the video, try it for volume, then I'm going to solve it now. Volume, what's the formula for volume? Length times breadth times height. See, before you can solve the physical dimension, you have to know their formulas. So like we said, understanding fundamental and derived quantities is very basic and primary to dealing with physics problems. Length, looking at it, is L. Breadth is also L. Height is also L. So it becomes L times L times L. That gives me L cube. Moving on further, speed. In some questions they are going to ask you, L cube is the physical dimension of dash. So if you know how to solve it, then you can easily bring it out. Speed, what is the formula for speed? Speed is actually distance over time. So looking at distance over time, we're going to check our dimension. Which of them is distance? Distance is still length. Then time is on its own. So the distance will be L, the time will be T. So I have L over T. But do I stop there? No. We need to go back to our indices class. Among the indices laws, we have negative index law. Negative index law in physics, in indices. Negative index law of indices. It says when you have 1 over a term raised to power maybe 2, it will be equivalent to that term raised to power negative 2, such that the negative is representative of the 1 over. So negative and a power is 1 over the positive power. The same thing happens when I write 1 3 raised to power minus 9. It gives me 1 over 3 raised to power 9. I'm also writing 4 raised to power minus 1. It gives me 1 over 4 raised to power 1, or 1 over 4, because 4 raised to power 1 is what? It is 4. So with that understanding, L over T is simply the same thing as what? This is simply L times 1 over T. And when you look at 1 over T, you can work it out with negative index. It becomes T raised to power minus 1. You see that now? T raised to power minus 1 is, this 1 over T is the same thing as 1 over T raised to power 1. So which is T raised to power minus 1 by negative index law. So take note of that. When I have, if I have 1 over T raised to power 2, it gives me T raised to power minus 2. If you are not getting it, go in the comment section below. You will see the link to our indices class, and then go over the class again, and then you're going to get it clearly. Now we'll go on to question 4. So we're going to number 4. Number 4 now, we want to calculate the physical dimension of acceleration. Acceleration. So we need to recall what is our formula for acceleration. Acceleration is velocity over time, or speed over time. So speed over time is acceleration, or velocity over time. They actually speaks the same. Now speed over time, if you look at your quantity, time is already one of the physical dimension. Speed is not one of them. So because speed is not, we are going to break down speed by putting the formula of speed. Now what is speed? Speed is actually distance over time, and everything all over this time. This time under is what I have there. Speed is what we have as distance over time, up. So at this point now, they're actually in line. The next question, I'm going to change the way I'm going to be writing it so that it's going to become very clear. Now, distance is length as a dimensional quantity. Time is there. So change distance to be what? L over time is T, and everything over T. So if you see now, this is actually L divided by time, then T divided by time. So we are going to write it in another format. This is the same thing as L over T, which is what we have up, divided by what? T down. If I rewrite it now, I'm going to be having L over T times what, this T here comes down, becomes 1 over T. See that now? So if you multiply that further, multiply it further, we're going to have L times 1 as L over T square. And this is the same thing as L over 1 times 1 over T square. And of course, applying your negative index rule, 1 over T square gives you what? T raised to power minus 2 as your 1 over T square. So this is the physical dimension for acceleration. I'm going to solve it in another way. And then that's the way I will use to progress further, because we're going to be dealing with longer questions solving physical dimension. So how will I solve this? Let's go for number 5. Number 5 is force. What is the formula for force? Force is actually mass times acceleration. Mass times acceleration. So I'm going to ensure that all I'm writing is going to be in a straight line. Look at it very carefully. Mass is a physical dimension. Then acceleration is not any of these physical dimension. So this one that is not, we're going to open up with the formula. Mass itself is there. So mass, that is this, times, what is the formula for acceleration? Speed divided by time. So you see, I'm not writing speed over time like this, though they are the same thing. But for more understanding in solving, I would rather write it like this, because when I finish solving it, you're going to see why I'm writing like that. Speed divided by time like this is also the same thing as speed divided by time like this. So we have that in that way. Now let's progress further. Speed divided by time.